All right, let's work this out together. But first off, just want to let you know the answer is letter B. All right. All right. Now, first off, so what? Obviously, that's a problem about the relation between linear speed and angular speed, right? So now everyone should be very familiar with the formula. V equals the radius r, right, times the angular speed omega, right? The question says, how fast are the tires turning? So are they looking for the V or omega? So are they looking for the linear speed or the angular speed? So car wheels, right, tires, they're turning. How fast they're turning? Angular. So Max, could you tell us that what makes you realize that's angular speed you're looking for?
Because you're finding how fast the tires are turning. Tires are round and like you're finding how fast that is.
Well, that's actually a pretty intuitive way, right? So you're more towards angular speed since you're talking about something is turning, right? Yeah, I think that's good enough. Or also, did everyone notice the units they're providing us in the options are kind of strange, right? So revolutions per minute. So it's okay if it's per minute, per second, per hour, but at least that they're talking about how many revolutions, right, within a minute. So I guess that it's, well, at least not some sort of regular speed, right? And of course, my previous class mentioned that. What do you think that is? 47 miles per hour, right? Well, that has to be the kind of speed that you used to know, right? And it's going to go with the V, so that's why it's definitely looking for the omega. So we're going to put omega as V divided by R, right? If you just invert that formula, and we do have everything, right? But it's just their unit's not ready. So I have the V, and I'm going to put it in a, complicated manner, but later on it's going to be easier for us to do the conversion that way, right? So mph, right, miles per hour. So 47 miles per hour or an hour. Now please be very careful with word problems when they try to tell you something, but not directly. So the diameter is 27 inches, which means that the radius has to be half of it, right? 13.5 inches. All right, so we're going to divide that by 13.5 inch, right? And also it looks like a complex fraction, right? Let's write that in a bit nicer way. So you have a division, right? So if you do what they call keep change flip, right? Or if you realize that divided by 13.5 is equivalent to multiply with its reciprocal, 1 over 13.5 inch. All right, so now all we have to do is convert all those units to the one we want, right? So we don't want hours. And also miles, need to be eventually into inches somehow. And also we have to figure out how to get the revolution back in. All right, so we're going to start by rewriting the original expression here. And we're going to think about how to go from the unit, let's say, well, let's go with the easy one. So how about we first go from hour to minute? All right, so let's go ahead and multiply a converting factor. That's going to take us from hour to minute. And I want this factor to have hours on the top, so we'll cancel the hour originally, right? That was on the denominator. Now, when it comes to the numbers of hours corresponding to certain number of minutes, right? And you divide them to get unity. So I'm sure you can see that it's gotta be 1 hour corresponding to 60 minutes, right? And please remember that sometimes, people can help thinking about, let me just put 1 right? Because since I said I want a unity from the converting factor. But you know that 1 hour divided by 1 minute is not really 1. Okay. They're very different, right? But at least that 1 hour is the same thing as 60 minutes, right? So everybody knows that. All right, so now hours cancel, right? So you're left with a minute. That's exactly what I want. So now the harder part is to go from miles all the way to inches. That's why I have those converting facts. And we can do it like one at a time, right? To go from mile to yard, then yard to feet, feet to inch. So using converting factors, you can keep multiplying these things in a sequential way. So that, I mean, yes, even it's tedious to write, but at least that it's straightforward enough. All right, so let's first go ahead and find the converting factor that takes us from miles to inches. Oh, by the way, so if you're thinking that, can we go from inch all the way back to mile? I mean, you could, but it's always going to be easier to go from a bigger unit to a smaller one, as you will see that later on, even though the numbers are big, but at least that you're not getting some crazy fractions or decimals. Anyway, oh, my bad. I mean, yard. All right. So as you can see that if we have 1 mile, which is the same as 1760 yard, I can put 1 mile here, right? 1760 yard. Now miles cancel, right? So you're stuck with the yard, right? For now, because now you're gonna go from yard to feet, right? So we put 1 yard, which is the same thing as 3 feet, right? Yards are gone. Go to the right a little bit. And so now we can go from feet to inches. That's 1 feet corresponding to 12 inches, right? And feet are cancel, and also inch are cancel. Okay. So now let's get all the numbers multiplied out on the numerator. 47 times, well, we have 2 ones, right? Don't worry about them. 1760 times 3 times 12, right? All over 13.5 and 60. Okay. Now, unit-wise, you have minutes on the denominator, right? Well, but there's no units left over on the numerator, right? But should I put the radians back in? Or if I were to put radians here, does it make sense to you guys? So that brings us to the question: what was that little trap that was like a big deal yesterday, right? When you try to use the formula V equals R times omega, right? What kind of units must you use for omega when it comes to angles? It could be per minute, per hour, per second, but when it comes to angles, it can never be anything other than radians, right? So now you might say, well, I didn't even see radians, right? How do you know that you're gonna put the radians back in? Because it's by design. Remember, it was how we define the angle in radians and how we use that to find the relation between omega and v. That means the omega, if you do everything right the right way using this formula, that the omega is eventually going to come in radians. Right? But that's still not what we want, right? We want at the end of the day revs, a number of revolutions. So we're going to do one more conversion from radians to the number of revs, right? So now you guys gonna have to find me those 2 numbers to make sure that the last converting factor has to be a valid one. So what do you say? How many revs corresponding to how many radians so that you get a unity from this converting factor? Alani? 1 rev is 2 pi radians, right? Or later on you might end up going with 1 rev equals 360 degrees, right? But I guess that it is the number of radians that sometimes people find reluctant to accept, right? There you go, right? So radians are canceled. So now you see that you're on the right track with the units. Now number wise, I mean, of course, there's nothing too crazy here, right? Just type everything in the calculator. So I'm sure that you're gonna get something close to 585, and it's gonna be rev per minute, right? But let me zoom out, so that you guys can take a picture for a reference, right? So now if you're lucky enough to be assigned that problem in a quiz, I'm expecting you to show me the perfect work. It doesn't have to be exactly like I do it. So as long as you get it right, and I'll go back and see that if your work is relevant, then you'll be fine. But you have no excuse not to be able to work it out in a quiz. All right. All right. Let's say, yeah, that's a quick warm up, right? Just to remind you what we did. And trust me that this is probably the only tricky part of 5.1. Because I'm sure that now you guys are okay with the radians, right? Even though it's weird, but it's not hard to deal with unless you remember some facts. But this sometimes not just requiring the facts, but also be alerted, right? And be patient. Not to mention that I'll say that there's so many things that can go wrong, right? Just because that you guys are young and can't help making small mistakes all the time, right? Anyway, now let me forgot to mention that I suggest that all of you try number 17 later, whenever you get a chance, since you just saw like a complete work for a similar problem. Give it a try since you're gonna have to work on it anyway before you come to the quiz, right? Work it out, or if you do have issues, get it resolved by coming to my office hour as soon as possible, right? Anyway, but I'm not gonna go over that in class because that's pretty much the same as the one you just saw. All right, now, this is what I was asking you guys, at the end of the last class, right? To memorize the definition of these 3 classic trig functions, right? Which are sine of theta, cosine of theta, tangent of theta, where theta is an acute angle in a right triangle, right? And also, I'm assuming that you guys are okay with those names, right? The opposite side, the adjacent side, right? Hypotenuse, and you're quick when it comes to identifying those sides. If we're talking about a certain angle here, but if you could, at this moment, try to remember that the tangent is not as independent as you thought it is. It turns out that the sine and cosine are the most important thing, and the tangent actually depends on those two. You can just divide the sine and cosine to get a tangent. Okay. Now the last one, I mean, it's not a big deal because we're gonna go over it anyway, probably tomorrow. That's called Pythagorean identity. It looks, pretty complicated because you have the square, right? You have like an arbitrary angle, and later on, it turns out this identity works out for any kind of triangle, or even you don't even have a triangle. But at this point, just want to point out that if you do know the Pythagorean theorem, turns out that you have the same thing, but just written in terms of sine and cosine. Anyway, so let me give you 1 more minute to make sure that you guys are remembering the correspondence between the sine and the ratio of opposite of a hypotenuse, right? Cosine, right? Or a tangent, right? Because later, I'm gonna have you guys to try, quick activity. And just so you know that I planned for the Kahoot, and it didn't work out for the first 2 period, and Ashley was there to witness right? But I just figured out because I paid. Yeah, unfortunately. Yeah. Well, I think I can still afford like $40 a year. Um, uh, I'll try to get it compensated by the school if I can figure it out. Anyway, it's not a big deal. All right, so now Ashley, prepare to try it because you did it once already. All right, yeah. So I'll give you maybe another 10, 20 seconds. Quickly take a look at the definitions, right? And when we start, you have to put away your device, except for the phone because you need the phone for the clues. But laptops, right, or iPads, or any kind of notes, cheat sheets. Yeah, just go through it for now. All right, sign for 10.
We have to learn the other identity.
Not this one for now. Don't worry about it. Just know that the ratio of observant hypotenuse sine, adjacent of hypotenuse cosine, opposite of adjacent is the tangent. All right, so that should be good enough. All right, go ahead and join the Kahoot quiz. All right, just so you know, later there will be 4 options, and they are all the same for all 6 questions. So you just have to know that the first option is whatever, right? The second and third and fourth, right? And also, you need to be quick. So there will be only 15 seconds once I show the question. So as you read, I was, asking the students to figure out in class in an old-fashioned way. So that's why I might be able to kind of slow, to tell them the question, right, or repeat it. But this time, let's try it in a competitive way, right? So I'm not gonna say anything. So you see the question and it has 15 seconds for you to respond. Okay. And I did bring prizes. All right. So the first 3, well, actually, I don't know how they do that. Maybe they go by the quickest, and whoever gets the most, correct answer, and also being quickest, right? So there'll be some prizes. All right. How many students? 1, 2, 3, 4, 5, 6, 7. Okay. Yeah. What is that? You guys are making me nervous. What if I screw this up?
How do you fix stuff?
Wait, I thought there's 13 students. So why is the we have 12 students, right? Anyway, so let's see. All right. Okay, we do get everyone responded, right? Okay.
Oh my.
Is it too quick?
Yeah.
It's it should be like that. It should be like that, right? And you know what? You're competing with each other, right? So you're not trying to compete with a absolute like a trick expert, right? You just have to stand out, right, in a class.
Hey, bro.
All right, ready for the next one? All right. Wow. I didn't even read that question. Okay. All right, let's see the score. Oh. Do they take into account the time?
Yes.
Also, whoever gets the most question correctly, also the quickest. Okay, that's good. That's good. I like that. I like that. All right, next one. Ready? Okay. Oh. All right.
I don't even know if I'm right, but it took me so long to get that right. Like processing. No, for real. Like, what is this man saying?
Oh, okay.
Just repeating.
Nice.
That's what I was thinking. I was like,
All right. That was number 4, right? Okay. 2 more, I guess.
oh, actually, Jenny.
Wow. All right, last one.
I was not taking me so long to click. I did this and it click low, like, bro. This is so annoying. Yes. Yeah. So you know this, like, did I ask?
Alana.
Let's go, Alana. Let's go. Let's go.
Oh. All right, so now Ari, Ashley, Alana, you guys get to pick a prize, but Ari was number 1, so he gets to pick first. All right, so I have lunchbox, water bottle, and a luggage tag. You pick one. That's it's lunchbox.
So cute.
Carry your surprise. All right. Ashley.
Okay.
Yeah. All right. Yeah, that's fun.
That is for the class.
Yeah. So where's Rebecca now?
Rebecca left
Yeah.
us.
I know. Yeah.
Yeah.
I haven't seen her, on campus. She's to, yeah. Tell her that I was learning a lot. I've been learning a lot from her, the cuckoo thing. And I told the first 2 peers that this is probably the second or third time that I did the cuckoo in my entire career in this country, right? Because they don't have cuckoo in them. Anyway, yeah, but I think, yeah, it's kind of fun. And I do like you guys to be quick on those things. And I think that this is probably not, well, it is competitive and a bit, maybe stressful, right? But in a positive way, right? So I'll try to, do more of these in the future. But the bottom line is, where now we can make the activities or the kind of evaluation in class fun, you will have to memorize those boring facts, right? That's the only way for you to ace in this class, right? Not to mention, in the future. Um, all right. Yeah, let's get back to um some more boring facts. All right. So Oh, sorry, my bad. That's not the one I was trying to show you. Here. Yeah. So I think that if I'm gonna get some anxiety level rising, they're all six. They're all six functions. I will try not to stress you out. That I said, well, memorize three of them, right? That means, you shouldn't worry about the first column, sine, cosine, tangent. You guys are great, right? Or almost perfect. The second column is when things, gets, hard, not mathematically hard, right? Hard to memorize. So first off, and by the way, you do have to memorize all six, right? So next time I'll try to do another clue so you can have all six questions to confuse you. And you still want to be
Why are
fast.
you goal to confuse us? Do you?
I thought as an instructor, I meant to confuse you guys so that you can deal with it, right?
You think I've already suffered through this? So what?
Oh, I guess my teacher. Anyway, but the thing is, I do believe those standard tests are sometimes designed in a way to not necessarily super confusing students, but that's the way for them to make sure that they are getting students, who truly stand out. Right? Anyway, but don't get in the wrong way. Now let's take a look at the first pair. I hope that you feel very confident that you know very well about sine, right? Opposite of a hypotenuse. So now let's look at this ugly thing. So CSC, right, stand for cosecant, right? So if you've heard of the term secant or secant line back in geometry, so when they say cosecant, they're referring to something to do with a secant line, but it's not going to make a difference if you know it or not. So cosecant is the reciprocal of sine. And I say, how am I supposed to know? They're so different, right? Now, if you look at it this way, it is because they're so different. So magically they come together. But they're reciprocal of each other. Right. Now the second pair is cosine, which you also know very well, right? Adjacent of a hypotenuse. Then you have this guy, SEC, which is pronounced as secant. Right? Secant line. Right. So cosecant and a secant, they are somehow named in a similar way, right? One is the co-version of the other one. Okay? But cosine and a secant, they come together in a reciprocal way. Okay. Now the last pair is tangent and a cotangent. So to me, I think that is probably the easiest pair for you to remember because, hey, co-version of the tangent, right? So somehow they're related, right? But again, in a reciprocal way. So now, very realistically, right? How would you be able to try to memorize three more based on what you already know about sine, cosine, tangent? So I'm gonna share my way, and also the student from my first period told me how he did that, right? So I'm gonna share with you, his method as well. But they're not that different. Or at the end of the day, right? You find whatever that help you to memorize them. Or my philosophy is, you're gonna have a cheat sheet right before the test and memorize these things, a couple minutes before the test, and then as soon as you get the test paper, write them down, right? Because I'm not gonna memorize these things, even though I have to teach for for a living, right? And I do have the cheat sheets, on my phone, or I put it on my desk where I had to have the tutor. Then I can always look them up, right? And I never feel ashamed of looking things up because that's the way to go, right? But you guys have to do it because I mean that's how we push you guys to ace everything. So now my way to memorize these is first off, I'll just memorize tangent and cotangent are reciprocal of each other no matter what, right? So that's not even, something I'm gonna even try to figure out some fancy way. But I was looking at cosine and I tried to relate it to secant, right? I'm just trying to find myself, how do I see they better get together? My way is the way it spells, right? So COS, but somehow I see that SEC that you see that C and S are reversed. So it looks like that they're spelled but in a reverse way. So maybe they get together as a reciprocal. So I mean, don't laugh at me. That's my way to remember. Again, like I said, I'm just trying to find myself a reason to accept it, right? Now, well then that left me, only one pair, right? Sine and cosecant. And again, that's only two left over, so they have to get together. So my first year student told me this is how he remembered those two come together. He said that, look, among those four, sine, cosine, secant, cosecant, he sees that the cosine and the secant are the ones they're so different from each other. All right. It's like their twins don't look like each other, right? Biologically, it's possible. Think about this, that somehow cosine and secant are like twins, but they look so different. But magically they get together, right? I mean, it's odd, right? It's just a weird logic. But like I said, it's, however you can do to help yourself remember it, right? But at the end of the day, you have to remember all six, okay? Now, and by the way, that's in the book, you can find them. And let me show you something more. It probably upsets you. Because I guess that not many people had a good experience with geometry, and these are the conclusions, right? The two special triangles are the ones that you were taught, back in geometry, but there are some conclusions that I do still want you to remember, so that you're better off later on using them to figure out some problems. Okay. I just want to make a few comments. So the first one here is a isosceles right triangle. So it has two acute angles, right, both equal to 45 degrees, and the right angle there. So the numbers they labeled next to the three sides are not necessarily the actual length of, the side. Okay. But what we do know is if you go by the ratio, say the ratio of two shorter sides must be 1 to 1. That means they're equal, right? Isosceles triangles. And the ratio of the longer side, which is the hypotenuse, right, to one of the shorter sides will be radical to 1. Radical 2 to 1. Okay. And the reason why I have to emphasize that you're using the triangle for ratios, because that the trig functions are all about the ratios, right? Now the 30, 60, 90 triangle are slightly harder, right, for you to memorize compared to the 45, 45, 90. I do remember back in middle school, my teacher told us that, hey, look, 30 degree is such a special angle, right? The opposite side of a 30 degree in this right triangle has to be half of the hypotenuse. Once I learn that, then, I'm going to start labeling the shortest side, right, which is the opposite of 30, 1 unit, right? And the longest side is going to be 2 unit, right? Because 1 is half of 2. Then I'm left with the side that's in between 1 and 2. It's not the longest or the shortest. And the way you figure it out is applying the Pythagorean theorem. All right, so you're going to go with square of the hypotenuse minus the square of one of the, shorter sides. Okay. So yeah, so you do have to memorize that this middle side, right? The not the longest or the shortest is radical 3, right? And you go by ratios. And that's all you need to know about these two special triangles, right? So I'm not asking you to memorize them now, and to be honest, I do see that's completely meaningless for you to memorize. But you know, for the test, you know, purposes, that you need to know them. Right? All right, so now let's go ahead and try, you know, 3 problems in the first half of 5.2. And I'm sure that you'll be able to work on, you know, quite a few problems in that homework set based on your understanding of the first 3 trig functions, sine, cosine, tangent, and also try to recall how the remaining 3 are related to the first 3. Not to mention, you know, you get to see some special triangles going on. Anyway, now, first off, we notice that this is not a special triangle. At least not at the 2 special triangles that I showed you, right? But to me, you know, as a physicist, we do see that this triangle is also very special, right? Because who doesn't know that the longest side in this case is 5, right? But of course, you know, the way to figure it out is, again, using the Pythagorean theorem, right? So you're gonna take the sum of the square of the 2 shorter sides, right? And take the square root. You get 3 square plus 4 square, right? You're having to get 25. That's a perfect square of 5. So taking the square root, you get 5. Right. So we do have all 3 sides. And if you remember that all 6 trig functions are all about taking 2 sides and find the ratio of them. So now you can work out all 6 functions as long as you know how they're defined. All right, let's start with the first 3 that you guys are, you know, very quick memorizing, right, how they're defined. So sine, cosine, and tangent. So sine, opposite over hypotenuse. So in this particular triangle, the opposite of angle theta is A, right? Hypotenuse is C. So we get 3 over 5. If you want, you can put that in a decimal form, 0.6. Cosine, adjacent over hypotenuse, right? So you get B over C. It'll be 4/5 or 0.8. Okay. Now tangent theta, it will be opposite over adjacent. So that's A over B, right? 4, not 4, 3/4. Okay, or 0.75, right? Also, do you realize the 2 identity that I showed you on you know, a previous slide that I didn't ask you to memorize, but now you can see interesting that is, you simply just divide the sine by the cosine, 0.6 divided by 0.5, 0.6 divided by 0.8, or if you were to do the fraction, 3/5 divided by 4/5, okay, you do get 3/4, right? That works. Or if you check the square of you know, the sum the sine added to the square of the cosine, they add to be 1. Right? Magically. That's called the Pythagorean theorem identity. Anyway, so now how about we again try not to get any assistance from your notes, or just try to recall together with me, what do you think will be that weird function that's related to the sine? Oh, anyway, that's so cosine and secant, right? So that has to be max.
1.6666.
What function is related to the sine in a reciprocal way? Cosecant, right? Yes, it's the reciprocal of the sine, right? And since, like Max says, it's a repeated fractions, repeated decimals. So let's just go with the fractional form, right? So it will be 5/3. Okay, but you can put down the repeated, decimals if you want. So now, as you can see that here, the secant is the reciprocal of cosine. And by the way, so the reciprocals are relative speaking, right? If sine is the reciprocal of the cosine, sine is the reciprocal of the cosecant, it's the case the other way around. So cosine is 4/5, so it has to be 5/4 for the secant. Oops. The last one, cotangent, that should be the easy one, right? Cotangent is just the reciprocal of a tangent. All right, so you get 4/3. Okay. I mean, it's not too bad. But you have to be very patient. All right. To get all 6 written down, or try it for a few times on your own, or try them without any assistance from the notes and the homework. And later you'll find it very natural to do that, and also quickly. All right. Now let's do something very similar with the help of a special triangles. Oops. Start with the easier one. So the one with the 45, 45, 90 degree. Right. And also we get to try those, ugly functions, right? Cosecant and secant. So let's start with cosecant 45, right? If you were to use my logic, cosecant and secant looks like they're dispelled in the opposite way, right? In a like a inverse way. So I'll say that it will be the reciprocal of sine 45. Okay. Now sine 45 is opposite over hypotenuse, right? So now 45 degrees over here, the opposite is 1, right? The hypotenuse is radical 2. So this is 1 over radical 2, right? So now if you take the fact that dividing by a fraction is equivalent to multiplying to reciprocal, or keep change flip, right? So I'm sure that you're going to get radical 2, right? Either way. All right, so now secant 45 degree, right? So that's going to be related to the cosine, right? Now, do you realize that due to the fact that the special triangle 45 degree has 2 sides that are equal to each other, sine and cosine are equal to each other, right? Sine 45 is the same thing as cosine 45. So you get the same thing as 1 over radical 2 on the denominator. So if you simplify it, it becomes radical 2. Okay. Now, cotangent 45, right? I mean, you don't have to, but it won't hurt, right? If you try to, again, relate the cotangent 45 to the tangent 45, even though it's trivial in this case, because you see that tangent 45 is opposite of adjacent, which is going to be 1, right? So you get 1 over 1, and it's going to be 1, right? And you see how nice it is, right? Even for those ugly versions of the 3 trig functions, as long as you're dealing with the 45 degrees, that you have a lot of things repeated. Not to mention you have the sine, you had the tangent cosine 45 to be exactly 1. Okay. All right, so one more, right? We still have the 30, 60, 90 triangle. All right, so let's give it a try. And you already see that the whole process, right? So that's why they probably don't want us to keep doing all 6 functions anymore, right? Somehow that sine cosines are probably more intuitive now, so they want us to try the tangent, right? Say tangent 60 is right here, right? So tangent is opposite over adjacent. Opposite is radical 3 over the adjacent is 1, right? So radical 3. Tangent 30 So it's gonna be the opposite again over the adjacent, but then relatively speaking, the angle is different, than the opposite adjacent are not the same, right? So opposite of 30 is actually 1. The adjacent of 30 is radical 3. Okay, but they wanted to rationalize the denominator, and the way it works is to multiply both the numerator and the denominator by the same irrational number, right, which is radical 3. Okay, and you get radical 3 over 3, right? And that's all.